4-3 right angle trigonometry is the section for today. And so what we're going to be working with today are our 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. And for this chapter we're not going to be using the unit circle, we're just going to be using right triangles. And we're going to be using acute right triangles. So anytime we're looking at an angle, theta, we're going to need that angle to be between 0 and 90. Alright, so we have these definitions down here. Sine is opposite over hypotenuse. And just a refresher from geometry, what that means is that the sine of this angle is the fraction of whatever the opposite side length is divided by the hypotenuse over here. So if the opposite was x and the hypotenuse was r, the sine of theta would be x divided by r. The cosine is the adjacent over hypotenuse, and so on and so forth. You have the fractions there. And what we're going to use to remember this is the mnemonic device SO, CA, TOA. And what we mean by this is that the sine, S, is the opposite, O, over hypotenuse, H. And so on and so forth. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then we know that to go from sine to cosecant, we take our fraction and flip it over. So instead of opposite over hypotenuse, we go hypotenuse over opposite. And so we'll use those for a number of problems. We'll start with our first one here. We want to find the 6 trig functions of this triangle here. So the first thing we need to do is figure out what the hypotenuse is. And so we do have a right triangle, so we're going to use our Pythagorean identity and say that 3 squared plus 4 squared is the hypotenuse squared, and so that's going to be 5, since 9 plus 16 is 25. Square root of that is 5. So we know the hypotenuse is 5. We have all 3 side lengths, so at this point we can say that the sine, which is opposite over hypotenuse, the sine of theta, opposite means go away all the way across the triangle from the angle, so 4 over the hypotenuse is 5. The cosine of theta is adjacent over hypotenuse. The adjacent side is 3, the hypotenuse is 5. Tangent, TOA, the end of the mnemonic, is opposite over adjacent. The opposite side we've said is 4. The adjacent side is 3. So those are our angles for sine, cosine, and tangent. And knowing that, we can go straight to the last 3. Cosecant theta is sine flipped upside down, 5/4. Secant theta is cosine flipped upside down, 5/3. And the last one, cotangent, is tangent flipped upside down, 3/4. So go ahead and see if you can knock this out yourself for problem 7. Alright, so sine is opposite over adjacent. I'm sorry, opposite over hypotenuse, which is going to be 9 over 41. Cosine is adjacent over hypotenuse, which is going to be, we don't have adjacent, so we need x. So we're going to say x squared plus 9 squared equals 41 squared. So this is 81. 41 times 41, let's go to the calculator. $1681. And so x squared is going to be 1600. We do the square root of that, x is going to be 40. Alright, so the adjacent side becomes 40. The hypotenuse is 41. Let's fill in the tangent. Opposite over adjacent, 9 over 40. And so now we can flip these over to get secant, cosecant, and cotangent. The flips of the previous 3, 41 ninths, 40 ninths, and, I'm sorry, I skipped one. 41 over 40, went too fast. And the last one, cotangent, will be the flip of tangent, 40 over 9. Okay? All right, so in this case, if we have the side lengths, we can figure out what the cotangent of the angle is going to be. In our next one, we're going to look at some specific angle values for theta. So in this case, we're going to look at the 45, 45, 90 triangle. All right, so the 45, 45, 90 triangle has specific side lengths. It'll always have a ratio of 1 on the legs and √2 on the hypotenuse. Okay, always. So knowing that, we can plug in. We have all three side lengths. We can find the sine of 45 will be the opposite over hypotenuse. The opposite side is 1. The hypotenuse is √2. And that would be our answer if we could leave radicals in the denominator, which we are not allowed to. So we'll multiply top and bottom by √2 and get √2 over 2. To do the cosine, we're going to get the exact same answer because in this case the adjacent side is also 1. So again we'll have 1 over √2, which above we proved was √2 over 2. And then to get our tangent of 45, opposite is 1, adjacent is 1, and so the tangent of 45 is just going to be 1. All right? We've actually looked at these numbers from our unit circle, but now we're proving them with right triangles. So see if you can, using this triangle, 1, 1, √2, tell me what the secant is of pi over 4, which is another way of saying 45 degrees. Remember how we convert to degrees? We would take this and go 180 over pi to convert and get degrees. Okay, 180 divided by 4 is pi. Okay, the secant is 1 over the cosine, and we determined that the cosine was √2 over 2. The secant would be the flip of that, 2 over √2. Let's clean up the denominator, and we'll get 2 √2 over 2, or just √2 as our final answer. All right, so very specific numbers for 45-degree triangles. Very specific numbers also for a 30, 60, 90 triangle. All right, so those are the other numbers from the unit circle. 30 degrees, 45 degrees, and 60 degrees are the important angles. All right, so now looking at this, let's figure out what the sine of 60, sine of 30, cosine of 60, and cosine of 30 will be. So the first one says sine of 60. That's this angle down here. So from that angle, we want to go opposite, √3 over hypotenuse, 2. And we've got an answer, √3 over 2. Let's look at the cosine of 60. From that same angle, the adjacent side is 1, and the hypotenuse is 2. So the fraction is 1/2. Now, let's go over to the other angle, the 30-degree angle, up here. The sine of that angle is going to be opposite, 1, over hypotenuse, 2. And the cosine of 30 will be adjacent, √3 over hypotenuse, 2. Take a peek at what looks similar here. Sine of 30 is exactly the same as cosine of 60. What we're saying here is that in a triangle, the sine of one angle will be the cosine of the other angle. Because what we're doing is we're switching which side is the opposite and which side's the adjacent. And we'll come back to that in a second. But for right now, let's see if you can do the cosecant of pi over 6. First question is pi over 6 30 or 60 degrees? Let's cancel it. 180 over pi. What's 180 divided by 6? That is 30 degrees. So we want the cosecant of 30 1 over sine of 30. Sine of 30 was 1/2. So the cosecant is 2. All right, so those are our special triangles, the 45, 45, 90, and the 30, 60, 90.